This is called direct imaging, and very few exoplanets have been found this way. Most exoplanets are found by using the transit method, which measures the dimming of a star as a planet passes in front of it. We can also find exoplanets by measuring the star's light spectrum for signs of a planet pulling on the star, causing the light to shift, or finding them using gravitational lensing. Using all these together is allowing us to find more exoplanets every day in the vast universe. If we're going to look for exoplanets that could support life as we know it, the first place to look are planets that orbit their host stars in the habitable zone, or what some scientists call the Goldilocks zone. This is the area around a star where it's not too hot or too cold for liquid water to exist. But the planet also has to be the right size, and the type of star that the exoplanet orbits has to be a certain type, and it should be stable. Our own sun, a yellow dwarf, has had a stable existence for over 4.5 billion years. But this is not always the case for different stars in other systems. But we'll talk more about different types of stars in a moment. First detected by the HARPS telescope in 2016, Proxima b is the closest alien exoplanet to our solar system at 4.2 light-years from Earth. It lies in the habitable zone of its red dwarf star, Proxima Centauri, and was thought to be a minimum 1.3 Earth masses. But a new telescope named Espresso recently discovered Proxima b to be only 17% more massive than our planet, making it more Earth-like than had previously been thought, and a candidate for life, because it's the right distance from its host star to have liquid water. Scientists believed that the planet could be habitable, and future generations of superfast spacecraft could travel to the planet in search for life. But that same year, a massive solar flare had erupted from the red dwarf star Proxima Centauri that was 1,000 times brighter than the star itself. It hit Proxima b with 4,000 times more ultraviolet radiation than the Earth would get from a solar flare from our sun, and researchers believe that this could have wiped out all traces of life on the planet. But Proxima b is not the only candidate as a habitable planet. Scientists now say they've discovered 24 super-habitable planets, or exomoons, that could be better suited for the emergence and evolution of life. The concept superhabitable came from two researchers in 2014. René Heller and John Armstrong have stated it takes much more for an exoplanet to be habitable than just being in the habitable zone. Things that would make a planet more suitable for life as we know it means they could be older, larger, warmer, wetter, could have higher levels of oxygen, and a longer living star. Heller and Armstrong have proposed that the required size of a super-Earth would have to be 2 Earth masses because radioactive decay in the planet's interior would last longer to provide heat, and the stronger gravity would hold on to the atmosphere longer. These 24 super-habitable exoplanets were chosen because they have a star of the right size, lifespan, and lie in the habitable zone. Many of these orbit around G-dwarf stars similar to our Sun, but researchers also looked for exoplanets orbiting around K-stars, orange dwarf stars that are cooler, less massive, less luminous, and there are 50% more orange dwarfs than yellow dwarfs in the Milky Way. While these Sun-like stars might not sound ideal for life, they have a big advantage. Their lifetimes are anywhere from 17 billion to 70 billion years, compared to the 10 billion year lifespan of our Sun. If life started on a planet orbiting a K-star, life would have had much more time to evolve than life on Earth has so far. Considering it took complex life 3.5 billion years to evolve on Earth, and 4 billion years for advanced life such as humans, a larger size exoplanet could mean more space for landmass and habitat. These super-habitable worlds would also have a higher gravity and a thicker atmosphere, allowing beneficial organisms to travel through the air, spreading life. Planetary scientists say the sweet spot age of a super-habitable exoplanet is about 5 to 8 billion years. Of course, a more super-habitable planet would need water for life as we know it to survive. Planets with more moisture and an average surface temperature 8 degrees Fahrenheit warmer than Earth could make them more habitable, since we understand there is more diversity of life in warmer and wetter climates. Some of these more habitable planets could resemble the Earth in the early Carboniferous period, about 359 million years ago, when the planet had the climate of a tropical rainforest. Gliese 667cc is the next closest superhabitable exoplanet which orbits a red dwarf star in the Gliese 667 triple star system. Yes, 3 stars. If you were standing on Gliese 667cc, this is likely what you would see in the day sky. Gliese 667cc lies 23.62 light-years from Earth and is a minimum of 3.7 Earth masses. Another possible superhabitable world could be Kepler 452b. It's sometimes called Earth 2.0 and orbits a G-type star which is very similar to our Sun, except that it's 1.5 billion years older and slightly bigger. Some authors speculate that there could have been an ancient civilization on the exoplanet or the Moon orbiting it. But it's possible that we're now seeing a glimpse of the future fate of Earth, because the star it orbits used up its fuel and has expanded into a red giant. But there are other things that we should be looking for. So far, there has been no way to detect oxygen in an exoplanet's atmosphere. But soon things will change. On October the 31st, 2021, the James Webb Space Telescope is scheduled to be launched into space on an Ariane 5 rocket. The technology on the telescope is unlike anything ever designed. It's the successor to the Hubble Space Telescope and will be a powerful new tool in the search and study of exoplanets that could support life. The James Webb Telescope will move out 940,000 miles away from the Earth, well beyond the orbit of the Moon, where it will set up shop and orbit the Sun. It'll be the largest observatory ever sent into orbit and will use special cutting-edge optical science and engineering to peer into the unknown. Researchers say they've developed a new technique that will allow the James Webb Telescope to detect a unique signal produced when oxygen molecules collide. If this signal was found in an atmosphere of an exoplanet, that would mean it would have oxygen, and perhaps life as we know it, present on the planet's surface. Despite all this amazing technology, if a planet orbiting a red dwarf has an atmosphere similar to Earth's, it will need to be within 16 light-years for the Webb Telescope to detect the oxygen signal. After its 2021 launch, the James Webb Telescope will study the history of our universe, including distant exoplanets, other galaxies, and the first luminous glow of the Big Bang and the evolution of our solar system. But we may need something more powerful to look farther out into space. The Nancy Grace Roman Telescope will be launched sometime in the later 2020s and will have 100 times the viewing field of the Hubble Space Telescope. It'll probe the depths of dark matter and dark energy, the mysterious and mostly unknown phenomena that makes up most of the universe. The most exciting thing is it'll be able to make direct images of exoplanets, something not possible from planet Earth. But the main goal of its mission is to peer into the interior of the Milky Way galaxy, where it would possibly find thousands more exoplanets through gravitational microlensing. But if we do find life out there, we must remember the universe is fascinating and very diverse, and the best place for life, such as superhabitable worlds, might not be like Earth in any way we traditionally imagine. We're entering a very exciting time in human technology, and with the number of habitable worlds out there, it's likely that we will finally discover life on a distant world. The Kepler telescope was built for one purpose: to look at a certain patch in the Milky Way in search of exoplanets. The exoplanet hunter observed over hundreds of thousands of stars and discovered thousands of exoplanets during its lifetime.
Liftoff of the Delta II rocket with
Launched in 2009 as part of NASA's Discovery program, Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96-megapixel camera to process the light. Astronomers were interested in finding out just how many stars have planets orbiting around them, and how many of these extrasolar planets or exoplanets have conditions that are suitable for life to develop. In its 9 years in space, Kepler observed 530,536 stars and confirmed the existence of 2,662 new exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have star-facing sides with temperatures that can melt iron, and have entire hemispheres covered with oceans of liquid molten rock. Other exoplanets the size of Jupiter orbit not one but two stars. If you were standing on the surface of one of these planets, you'd be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars inside what's known as a habitable zone, or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called K2-18b. In September 2019, two scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. Situated 124 light-years away from Earth, K2-18b is about 8 times the mass of Earth and 3 times as big. It orbits a main sequence red dwarf star called K2-18. A red dwarf star is the smallest, coolest star and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. To find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. K2-18b is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. Kepler first discovered the planet in 2015, and since then its composition has been studied using other telescopes, like the Spitzer and Hubble Space Telescope. Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the star dims slightly, and that's how we can tell that there's a planet there. The level of dimming and how long it lasts gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1/109th of that of the Sun. So, for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.008%. Kepler's cameras had to be sensitive enough to detect this minute change in the luminosity. Using the same method way back in 2014, Kepler first found a potentially habitable exoplanet. Kepler 186f ignited the imaginations of space nerds everywhere when NASA announced its discovery. Now a new study indicates the exoplanet, 500 light-years away, may also have seasons and a climate similar to our own. New research out of Georgia Tech University has analyzed the planet's spin and axial tilt and found that its tilt is stable like Earth's, which makes it likely that Kepler 186f also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being reanalyzed in conjunction with data from other telescopes. One such planet is Kepler 1649c. In mid-2020, while combing through old Kepler data and matching it against new data from the Transiting Exoplanet Survey Satellite, or TESS, astronomers confirmed the existence of another exoplanet with very favorable conditions for life. Kepler 1649c, located 300 light-years from Earth, is very similar to Earth in size and estimated temperature. This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from its host star, which is also a red dwarf, is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. Kepler 1649c provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. But before we get ahead of ourselves, it's important to note that out of the 2,662 exoplanets identified by Kepler, only 16 of them lie inside the Goldilocks zone. And out of these 16, some of these planets are tidally locked with their parent stars, meaning that only one hemisphere of the planet faces the star, and this is not ideal for life. Others are more like a smaller version of Neptune than a larger version of Earth, and planets similar to Neptune are expected to have a significant envelope of hydrogen surrounding any layer of water on the surface, with a planetary core of rock and iron. If the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath would be far too great to support life. On top of all of this, despite being cooler, red dwarf stars tend to be more active than Sun-like stars. Thus, the planets may be exposed to higher quantities of damaging ultraviolet radiation than what we're used to here on Earth. Because of this, surface temperatures can range between -100 and 116 degrees Fahrenheit or -73 to 47 degrees Celsius. That means the surface could, on average, be colder than Antarctica or hotter than Earth's most blistering deserts. Unfortunately, we just don't have the technological know-how to study the composition and atmospheres of these alien worlds and comprehensively answer all these questions yet. But don't despair. Based on the statistical analysis of all the Kepler observations, astronomers now estimate that 1 in 5 stars like the Sun have planets about the size of Earth and a surface temperature conducive to life. Given that about 20% of stars are Sun-like in our galaxy, that amounts to several billions of potential habitable Earth-like planets just in our Milky Way alone. Kepler not only focused its efforts in finding potentially habitable planets, in fact the bulk of its discoveries were strange worlds not suitable for life but fascinating nonetheless, like the gas giants, planets composed mostly of gases such as hydrogen and helium with a relatively small rocky core, also known as hot Jupiters. These planets orbit extremely close to their parent stars and are abundant in Kepler's data. One such fascinating example of a gas giant is KOI 5AB. Astronomers first flagged KOI 5AB as a potential planet way back in 2009. At the time, this elusive alien world was only the second planet ever found by Kepler. It slipped through the cracks a decade ago. Firstly, due to the enormous amount of data that Kepler generated, and secondly, because astronomers noticed that the main KOI 5A star had another companion star, making analysis very difficult for them. Indeed, the KOI 5 system was even more complicated than researchers realized at the time. By 2014, scientists had determined that the KOI 5 system actually harbors 3 stars, and it still wasn't clear if the planet KOI 5AB actually existed, or if the 2009 signal was generated by one of the companion stars. But thanks to additional data from the TESS satellite, scientists were able to confirm the existence of KOI 5AB. Planetary bodies on stable orbits in a multi-star system is quite a rare find, and the discovery of KOI 5AB is expected to add a lot to our understanding of planetary formation. Other exoplanet types identified by Kepler include super-Earths. They're more massive than Earth, yet lighter than ice giants like Neptune and Uranus, and can be made of gas, rock, or a combination of both. Lava planets are super-dense, larger-than-Earth worlds in close, hot orbits around their parent stars. Some of them, known as Chthonian planets, are likely the remnant cores of evaporated hot Jupiters. And finally, Trojan planets, planets of various size found in strange locations, and sometimes even as companions to larger planets, though none have been certainly identified yet. Kepler was finally retired on the 30th of October 2018 as it ran out of fuel. The telescope was deactivated with a good night command sent from mission control the next month. Coincidentally, Kepler's retirement fell on the 338th anniversary of Johann Kepler's death, after whom it's named. Although not operational anymore, these incredible discoveries predict a near future in which astronomers will use new and advanced telescopes on the ground and in space to more deeply understand Kepler's numerous finds. One such telescope is already slated to go up into space in 2021. The James Webb Telescope will take a much closer look at some of these Kepler objects of interest and hopefully will bring us closer to answering the question, are we alone in the universe? What do you think? Will astronomers find many more strange worlds buried inside Kepler's data? Let us know in the comments section below.